Oscilloscope. All right, so here's an example. Okay, so we have this, if you look at here, we have this curve that is this bridge. So we could model that by just taking a sine function and changing the different parameters on it, the A, the B, the C, in order for that to fit the data. All right, so shrink this a little. So down here are our sliders. And we're just going to move these, and they're going to change these parameters here so that this matches that shape. All right. So just by looking at it, it's kind of hard to read the red numbers. Okay, but where would our midline be on this? Let's see if I can zoom in some. Oops, that zoomed out. Nope. Zoom in. Okay, so if you were going to set a midline for the sine function, all right, where do you think that midline would be? About 1.5. Okay, so I'm going to take the A and move it to like 1.5. Or I'm sorry, not the A. Which one do I move to slide it up? Let me see. I think I covered over the, yeah, this one outside here. All right, so in this case it's labeled K. So if we made that, it's really hard to read because it's yellow. But if I made that like 1.5, well, that's pretty close. All right, so now let's do the amplitude. Okay, so I probably just have to adjust that. Maybe make it a little bit. So I'm just trying to get that top and bottom to be the same as the bridge. I think I gotta change this just a, yeah, that's pretty good. All right. Now we want to phase shift it. So I'm going to slide it right and left till it matches up. Pretty close. All right, and now I've got to change the period a little bit so that the curve fits it. So do I want to squeeze it or stretch it out horizontally? Yeah, I want to make the frequency a little bit higher so that these hills and valleys are closer together. So right now it's at 1.6, so maybe 1.8. Well, the more I make, the higher I make B, the more, there we go. So by just playing around with these a little bit, we can get an equation that's pretty close to modeling the curvature of that, of the truss structure in that bridge. All right, so if you collected data and you noticed that the data you collected was periodic, then you could do the exact same thing. Of course, there's programs that do it. That'll take your data and fit it to your, and then fit a sine equation to it, just like we did just by playing around. And let's see, I'm pretty sure there's one on your calculator. I think it's under, let's see, your calculator does lines of best fit, and it's usually under, I'm going to go under Math, Calc, nope, let's see, where was that? Math, nope, number, okay, stat, calc, there it is, okay. So under, I hit stat, the stat button, and then calculate. And what these do right here this would fit a line to your data. This would fit a parabola to your data. This would fit a cubic equation, x cubed, to your data. Let's see if there's a sine and cosine. Is there a sine? Yep. Okay, so you could plot your data, choose this function, and it'll create a sine function that fits your data as close as possible. All right. Okay, so that's the gist of what we're doing with sine, which is one of the reasons why you learn mathematics, is to be able to create equations to make predictions or to model a phenomena. All right, so if you would go to section C, which is page 9. Times would be. All right, so let's go back to actually how you do it. So here you've got some data about the temperature in Cape Town, South Africa, over a 12-month period. And these are the temperatures in Celsius. So if we plotted that data right here, all right, so for example, January is about 28 degrees, etc., we see that this graph appears to be behaving with a periodic property, because it's repeating over and over, which is a good sign that you can probably fit it with a trig graph. All right, so the first thing we want to do is we want to determine what the amplitude of our trig function is going to be. All right, so the amplitude would be any multiplier out in front. All right, so to get the amplitude up here, our amplitude is the value of A. All right, we're going to do that by finding the difference between the max and the min values and then dividing that by 2. Okay, so go through, and to get your amplitude, find the highest temperature and the lowest temperature. And then we're going to divide that by 2. We're going to find the difference between them, and we're going to divide it by 2. And that's going to give us our value of A. Okay, so what do we get? What's our high and our low?
28 minus 15.
Our high and our low, yep. All right, so down here we're going to take 28, which is our max value, and 15, which is our min value, and subtract those two. And then divide by 2. So our amplitude is going to be 6.5. So this is how high or how low it goes below the midline or our offset. So the next thing we're going to do is we're going to find the value of D, which is the vertical shift. And earlier I mentioned that this was, we called this also the offset, but it's the midline. So to do that, you're going to find the average of the max and the min values. Okay, so this should be the vertical shift. This should be the average of the two, so we better make that a plus, not a minus. So we're going to find what's the average between 28 and 15. Okay, so our D value, our offset, is going to be 28 plus 15 divided by 2. Right, and that gives us, what, 43 over 2, which would be 21 and a half. So D is 21 and a half. Okay. All right, so let's just put that on our graph so we have an idea. Okay, so we're going to have a midline around 21 and a half. Okay. Now, if you're one of those people that are very particular about lines and you want them to be straight, here's some straight edges. Probably I noticed Kathy, you seem to be pretty particular when it comes to straight. I saw you measuring with the dry erase marker. All right. So our midline up here, about 21 and a half. So I'm just gonna, that's about 25. So we'll just kind of estimate where our midline is. So I'm going to guess something sort of along those lines. Oops, clean that up. Okay, so there's your midline, and then your graph, this should go about 6 up, and if you went below, it would be 6 down. Okay, it should, that should fit our data. Okay. So there's our D value. So this would be y equals 21 and a half. And then our top line, our top part of our graph, so this little distance right here is your amplitude. That should be about 6.5. That's what we got for our amplitude. All right, so we've got the amplitude done, and we've got the vertical shift done. All right, so our next step is we want to determine what the period is. Okay, so to find the period, we're going to look at the time it takes for the graph to repeat. If you don't have a full circle or a full cycle, then you use the fact that the period is the x value of the minimum minus the x value of the max times 2. All right. If we don't have a full cycle to work with on our data, we can create it by doing this. Okay. So, for example, on this one here, if we took the x value of the max, which is right here, and we took the x value of the min, where was the min? In June, July? Okay, if we took those two and found the difference between them and then multiplied that by 2, that would be our period. Okay? Now, in this case, we know we were given what the period was, 12 months. So we don't really have to figure anything out here, okay, because we were told what the period was. The period was 12 months, right? So in our drawing here, okay, the problem tells me that the period is 12 months. All right, now what we want to do is find the value of B. So to find B, we're going to solve, okay, the period is equal to 2 pi over B. Okay, so we're going to solve that equation for B. Well, if the period is 12, sine is normally 2 pi, so I solve that equation. So multiply both sides by 12, or by B. I get 12B equals 2 pi. Divide by 12, and I get B is 2 pi over 12, or pi over 6. Okay, so that's our value of B. Okay, so we know we got our A, we got D, we got B. Okay, questions? All right, so the next thing now is find the phase shift. How much do we have to slide it so that it fits our graph? All right, so to get the phase shift, you're going to take the period and divide it by 4. And then subtract that result from the x-coordinate of the max to get the phase shift. All right, so to do this, all right, our phase shift, this is what we've got so far, real quick. T, I'm just going to write out what we got so far for our equation. Okay, A is 6.5. Sine, okay, the B value is pi over 6, parenthesis, T, that's the month, minus C plus 21.5. Any questions on where that's coming from? No? All right, so divide the period by 4. All right, and now subtract, so that gives you what, 3. Okay, now subtract that from the x-coordinate of the maximum point to get your phase shift. So what's that give you?
-2.
Okay, and so you took this divided by 4. That gives you 3. All right, what's the x-coordinate of the maximum?
January, which is 1.
Okay. So if we did, we're going to the x-coordinate of our max. Okay, is 1, and what was the max was what, 28? Okay, it was 1, was it 28? What was the highest one? 28, okay. So the x-coordinate of the max, 128 is 1. Okay, so what's it give you for the phase shift? Mm-hmm. Okay, so we're gonna the x-coordinate of 128 is 1. So then we're gonna take 1, take away 3, and we get -2. So that's our value for C. All right, so what would our equation be now? (6.5) sine 6t plus 2, because if I put C as -2, that becomes a plus 21.5. Okay, now let's see if it works. All right, so let's pause here. All right, so once we typed in those points, then we typed in what we got for our calculations, and we're pretty spot on there in terms of what that